Yes, let us start another chapter, which is on the functions, right? So let us now start looking at what is a function. So the title for today's class is, or the topic for today's class is, what are functions, right? So we will look at what are functions and we look at the precise definition of a function. Because if I ask the students, you know how to deal with the functions. But if I ask the students to define a function, I think many of you will not be able to define. So we'll look at when is a mapping or a relation called a function, right? And that is a very core idea in IB mathematics as well as A level or O level mathematics, because that all deals with functions. And once the definition of functions becomes clear to you, then many other things will start becoming or making sense to you, becoming clear to you. So let's look at what is a relation and when is a relation called a function in mathematics, right? So what I'm going to do is I'm going to first show you something called y is equal to x plus 3 and x equal to y square. Now what are these called in mathematics? So we have two variables x and y for which I have given a relationship. This is how we define the relationship in mathematics. In real life, our relationship is with our children, our students, right? So all of you have a relation with your father or your mother or your brother and sister if you have. So that is called relation between humans. So you need two things or two persons for the relation, right? You and your sister, or maybe you and your mother. Similarly, in mathematics, we need two variables to define the relations. And generally, we take x and y as the two variables. So if y is x plus 3, then we have established the relation between x and y. That means if I say x is 5, then y would be 5 plus 3, 8. And another relation that is defined here is x equal to y squared. So if x is 9, then y square is 9, and therefore y is plus 3 or minus 3, the square root of 9. So these are equations of two relations. This can also be plotted on as a graph. So the relation can be given in terms of a mathematical equation where we relate x and y, or you can also be given a graph, which can also, make us understand the relation between the two variables x and y. So a relation is just any set of points which connect the two variables. So if I have x equal to 3 here, y would be 6. If x is 1, y would be 4. So I'm able to find what is called the relation of the connection between the two variables x and y, right? That is a relation. Now the question is, when is a relation called a function? The other word for relation is a mapping. Okay, so it can be called a relation or a mapping in mathematics. Mapping means for x value, I know what is the y value. So x is mapped to y by some relation, by some mathematical form or mathematical equation. Now the question is, when is a relation called a function? So for that, I need your attention towards these four relations or four mappings, what we call. These are very, very good mappings to understand the core idea behind a function. So if you look at first of the relation, y is equal to x plus 3. Second one is y is equal to x squared plus 1. Third is y is equal to plus minus square root of x. And fourth is plus minus y is plus minus square root of x squared. There are four different relations, but all of them have certain characteristics which is not present in others. Let us see what is that. Y equal to x plus 3. If I input the x values as -2, 0, 6, and minus 11, then I get the y values as 1, 3, 9, and minus 8. Isn't it? When x is -2, then -2 plus 3 is 1. So we get a different value of y for each different value of x. And this is called one-to-one mapping. One-to-one. One-to-one means for every x value that I am inputting, I am getting a different y value. That is called one-to-one mapping. Second is y is equal to x square plus 1. Now you see, you know x square. If x is 2, then x square is 4. If x is minus 2, then also x square is 4. So minus 1 will be, square of minus 1 will be 1, 1 plus 1 will be 2. And if I again input minus 1, then I am getting 2. Because 1 square is also 1 plus 1, 2. So both minus 1 and 1 here, the two x values are mapped to the same y value of 2. There are other values also, like 0 is mapped to 1 and 2 is mapped to 5. But our focus should be here on minus 1 and 1, which are mapped to 2. Right? And this is called many to one mapping. Many values of x. The first word is always for x. The first one here in the mapping is always for x values. And the second is for the y values. So many x values. Many means more than one. More than one value. More than one value of x is mapped to same value of y, or one value of y, which was not happening in the first mapping. There were no two different x values which were mapped to the same y value. Now going forward, y is equal to plus minus root x. For 0 square root, I have 0. For square root of 4, I have minus 2 and 2. So now for same x value, we have two different y values. So it is called one to many, because now y's are more than 1, where x is only 1. If I take 9 here, it would give me plus minus root 3, which is the square root of 9. Right? So this is called one to many. And in the last one, if you do plus minus root x square, if I take minus 1 square is 1, and then again its roots are plus 1 and minus 1. So minus 1 is mapped to two values of y. Similarly, minus 2 square is 4, which is also mapped to two values of y. So this is many to many. Many values of x are mapped to many values of y. Now out of these four mappings, the first two are called function. These mappings classified as function, whereas the next two are not functions. Right? So the idea is that we should not get many here. That means x values should not be mapped to many y values. That is called a function. It can be one-to-one function. That means for every x, I have a different y. Or it could be that for two different x, I have one y. Y cannot be more than one value, whether x is same or x is different. Then it is called a function. So if y becomes more, it is like a machine in which you are inputting something and then you get an output. Now, when you change the input, you can get the same output. That's okay. But for the same input, we can't get two different outputs. For this input of 4, we are getting here output as minus 2 and 2, which means the machine is in repairs. It has become faulty and it is not called a function. So a function is a mapping, right? Function is called a mapping. Or if a relation is given as an equation and the substitution of any value of x in that equation results in one and only one value of y, then the relation is a function. It should not be giving us more than one value of y. Right? If I have an equation and I input x value and I get two different y values, then you understand that that is not a function. So we can get maximum one and only one value of y. Then the relation is called a function. This can also be defined in a different way, that a function is a relation in which no two different ordered pairs have the same x coordinate or the first component. What does it mean? It means that if I have ordered pairs 2, 3 and 2, 5. Now these are two different ordered pairs. But what's happening here? They have the same x value, first value, which means they are two different ordered pairs. So 2 is mapped to 3 and 2 is also mapped to 5. So for the same input of 2, I am getting two different y values, not a function. So that's the idea behind the definition of a function. So if I take some examples here to make it more clear, let's take we have some ordered pairs here. Right? Let's say we have some ordered pairs and we try to find. Yes. First one, if you look at this, or look at just the first values, 1, 2, 3, 4, the x values, they're all different. So it is a function. Again, you look at -1, -3, 3, and 1. All x values are different. It's a function. The C part, we have 2 map to 5 and again 2 map to -3. So 2 of the ordered pairs have same x value, not a function. Similarly, for D, you can see all the x values are same in all the 4 ordered pairs. Again, not a function. Right? In the E, -7, -5, -3, -1, all different x values, it's a function. Whereas in the last part, again, you see same x values in 2 different ordered pairs. So it is again not. When I say not, it means not a function. Isn't it? Not a function. That is the idea behind the definition of function. And the functions that we have got now, A part, the B part, and the E part. What kind of functions are they? Now look at the y values. Now to classify a function either as one-to-one function or many-to-one, right, which we saw are the functions. What we have to now see, we have to now see the y values. Are the y values same? No, all the y values are different here. So it's a one-to-one function. That means for every change in x, there is a change in y. Whereas in part B, you can see y's are not changing. -1 is also mapped to 2, -3 is also mapped to 2, 3 is also mapped to 2, and 1 is also mapped to 2. So many to 1, many values of x are mapped to the same value of y. And the f part was not a function, E is a function, where again you can see the y values are same, so it's again a many to 1 function. I hope this is clear and you will be able to now very clearly understand which relation is a function and which relation is not a function. Thank you, and I stop here for the time being, and we'll continue with the other ideas in this playlist now. So the playlist of functions have been started, and once a few things are clear, then I'll go back to the playlist of quadratics, because when I start discussing the domain and range of quadratic functions, you need to be very good at the concepts of functions. That is why I thought it better to start the functions also and then make the things clear so that we can take it to the quadratics and understand the quadratic functions also much better. Thank you very much.